Hey, welcome back. We are now going to look at transformations of exponential functions. Any of the transformations that we have studied, whether it be in Algebra 2 or so far in this course, can also be applied to exponential functions, and that's what we want to look at this time. We are starting off with the function 3 to the power of x. This is an exponential function because the variable is located in the exponent. They want us to, number one, go ahead and identify the transformations that are occurring. How can I get from this function to any of these functions? So we state the transformations. Then we will be using Desmos.com to have that visual component. We want to see what the transformations actually do to the original graph. Finally, be able to sketch both graphs and label. And by label, like when I go ahead and I look at the first one, what I get for 3 to the power of x, I will label as f of x. What I get when I graph 3 to the power of x plus 1, I will label that g of x. That's all we have to do for labeling. In fact, let's go ahead and just start off by graphing our parent function, 3 to the power of x. So I'm going into Desmos. My base is 3 to the power of x. There is the graph. So I'm going to sketch it. Notice we do have that horizontal asymptote. It is a curve-shaped graph. This is f of x. Now, how can I get from 3 to the power of x to 3 to the power of x plus 1? Notice I'm adding. Anytime you are adding or subtracting, that is a slide. This adding, in this case it's adding, okay? This time when I'm adding, I'm only adding to the x, and I know that because it stayed within the exponent. It's not a vertical slide where you're adding or subtracting at the end. That's what this would look like. If you are adding or subtracting and it stays within the exponent, that's horizontal. Okay, so they will not show you parentheses when they're doing this. Instead, you just have to know that if it stays in the exponent, it's only being applied to the x. So in this case, we have a horizontal. Adding and subtracting again is a slide, a shift, or a translation. The formula for a horizontal shift is x minus h, where h is the horizontal distance. Well, if the formula is x minus h, and in our function we have a plus, that means we placed a negative 1 here. If I placed a negative 1, it means that we are going to the left 1. So we have a horizontal slide to the left 1. Now they want us to go ahead and graph that on the same grid and see what happens. If I have 3 to the power of x plus, oh, see, it stayed right there. So what I have to do is go ahead and put parentheses. So x plus 1. You just got to be really careful when you're watching with Desmos. We want to make sure that that plus 1 stays up with the x. In order to do that, I did have to place the parentheses there. Notice the blue line, and this is one cool thing I want to point out. The blue line is our parent function. That is 3 to the power of x. The green is where it's 3 to the x plus 1. So we will notice what happened is the graph did just shift to the left. So we go ahead and we sketch it. This is g of x. So both of them are curve-shaped graphs. They're both curving upwards. They both cross the y-axis once. They both have a horizontal asymptote as we go to the left. Okay, let's look at the next one. This is the cool part too. I can just go ahead and get rid of the second function because they always want you to graph the original. So I can do the same thing. Here is my f of x. This is the shape of it. It's already on Desmos.com. And in fact, we could even go right now and do that for all of them because each time we're starting with 3 to the power of x. If I go ahead and this is f of x. Okay, so we have that. We see it's going upwards, that sort of thing. All right, now if I look at the next one, here's my 3 to the power of x. What is different? The transformation is that they are subtracting 2. Notice they're subtracting 2 to the end of the whole function. So they rewrote the original function minus 2 to the end. So that is a vertical slide, shift, or translation. If you are minusing, you're sliding the graph down 2. So now visually we want to see what happens to our parent function. So if I go 3 to the power of x minus 2. This is showing up in the purple. Notice what happened is it just went down 2. So one thing that I want to make sure as I'm sketching, notice that the y-intercept now is actually below the x-axis. That happened for, they have this one labeled h of x. So again, I just went ahead and I sketched it. Okay, next one. Let's get rid of this so I'm ready to graph. This is where we're at. We already have that. That is 3 to the power of x. If you have a negative sign, anytime you have a negative, and those are the last two transformations that we are going to look at, a negative means that you have a reflection. You're either reflecting over the x-axis or you're reflecting over the y. Remember, if your negative is out front of everything, it is going to flip it upside down. So that is a reflection over the x-axis. So this is a reflection. I was going to write flip there. Reflection over the x-axis. So let's see what that looks like. If I go negative 3 to the power of x. Look at that. It flipped it upside down. Super cool. Some of the, well, in fact, all the darn properties still stay the same. Look at this. It's still a curve. Okay, if I'm looking at this, they're both curve shapes. They both have one y-intercept. They cross the y-axis once. They both have a horizontal asymptote. If I zoom in close on this thing, oh, come on, buddy. There you go. There's close enough. If I zoom in close enough, notice it's not actually touching the x-axis. When you glance at it quickly, it looks like it is. But when you zoom in, notice that it is not touching and never crosses because that's that horizontal asymptote like we talked about at the end of chapter 2. All right, let's go ahead and move on to our last example. Again, I see a negative sign. A negative sign is always a reflection. If the negative is only going to the x, it's not out front of the whole thing, it is only with the x term, you're reflecting over the y-axis. So this is a reflection over the y-axis. Let's go ahead and see what that looks like. I have 3 to the power of negative x. Here's visually what that would look like. So it did just flip over the y-axis. This is j of x. So here was the original. They flipped it. Here is your j of x, 3 to the negative x. So again, really focusing on how those transformations can be applied to not only linear functions or single ordered pairs or quadratics. Now we're looking at exponential functions. And guess what, guys? We're still dealing with transformations. And you better believe when we go to logarithms at the end of the chapter, we're also going to transform logarithmic functions. So just keeping this kind of in the forefront of your mind, it's not going away. Just kind of become friends with transformations. They stay forever. Things to notice. Notice that the transformations, they may alter the horizontal asymptote, like when things slide up or down, like here it slid down. So now your horizontal asymptote for h of x would have been y equals negative 2. The y-intercept, sometimes, or in fact, more often than not, the y-intercepts were different when you look at the original function based off of the transformation. So that's why I said on the front side, yes, we had a horizontal asymptote at y equals 0. But once you do transformations, that can change. And on the front side of the notes, our y-intercept was always at 0, 1. But again, here, we're noticing that as you do transformations, your y-intercept will change. But the fact that it has 1 stays the same. Okay, there are some suggested assignments if you want a little bit more practice with exponential functions, whether you're graphing, making XY tables, practicing transformations. There are 15 pretty good questions that I thought were definitely worth your time in the book. You can find those on page 193. And then also there is a quick quiz just covering this material that is due today. Talk to you guys soon. Bye.